Hello, everyone. Thank you for attending today's webinar on HyperLynx correct model assignments for HyperLynx SI. Hopefully you will learn today how to assign simulation models in HyperLynx LineSim and BoardSim. So hopefully most of you are familiar with what HyperLynx signal integrity allows us to do is check our boards and pre-layout schematics for potential signal integrity issues. And this is a very valuable thing to do. Unfortunately, the only problem we have with this is you really have to make sure your model assignment is accurate as possible in order to get real-world results in the simulation environment. So it's very important to be able to understand what types of models we can use and how to properly assign those to our components, either in our pre-layout schematic or in our post-layout board file brought in from any of your PCB CAD tools. Okay, and then after that, we're going to talk about how to save our model assignments. Okay, we can actually use HyperLynx to automatically assign models to components in future simulation environments. Okay, so this can be really cut down your time, so you don't have to always, if you're using the same component, always map in that IBIS model or that SPICE model or that EBD model that you're trying to use for that particular component. So this webinar is hosted by Oasis Sales. My name is Kyle Lake. I'm an application engineer with Oasis Sales, and we have been a premier EDA partner with Mentor Graphics, now a Siemens company, for over 18 years. So you can see our states that we service down below there. Hopefully you reside in one of those. If you do, you can always reach out to me in order to get more information on any CAD tool solution for electronic design. I'm always happy to work out with evaluations, pricing info, or just general questions that you may have. So during this webinar series, we are partnered with TriLogic. So TriLogic is essentially our counterpart on the East Coast. So you can see the states that they service down there below, mostly in New England and the southeast side of the United States. Again, they have been an EDA partner with Mentor Graphics and have been established for over 30 years. So they work with Mentor Graphics as well as Omnify for data management solutions. Okay, so we are both happy to always help potential customers or existing customers with any type of technical information, pricing, evaluations, just to help you move forward in that. And again, we are both happy to work with Mentor, now a Siemens company, and provide our customers with even more electronic design solutions. So here's just a visual representation of kind of our respective geographies. Again, Oasis Sales is mostly responsible for the Midwest and Northwest side of the country, and TriLogic predominantly takes over the East Coast and Southeast side of the United States. So if you like what you see today, please feel free to check out our other webinars. We host these every week on different types of subject matter. So if you're interested in what you see and you want to learn a little bit more and see what else we've presented on, please feel free to check out our respective YouTube channels just by searching Oasis Sales or TriLogic, or you can find links to both of our YouTube channels on oasissales.com or trilogic.com. I just wanted to throw a quick blurb out there about my next webinar that I will be hosting, and that's going to be on PADS Professional Rigid Flex, talking about the Rigid Flex capabilities within PADS Professional. Here's my contact information. So if you have any questions after the webinar or would like to get a little bit more information, please feel free to either take a screenshot of that or just jot that down. I'll show this at the end of the webinar again, but please feel free to always reach out to me, and I'm always happy to help you out there. So as you may know, there is in the GoToMeeting, you have the ability to ask questions. So please feel free to ask a question. I do see a question that I had the wrong date there for my next webinar, so I apologize for that. I will send out some more information on that. But if you have any questions, please let me know. And if it's relevant to what I'm talking about now, I'll definitely dive into it. Otherwise, I can definitely get to you after the webinar is wrapped up. Okay, so without further ado, let's actually hop in to talking about how to correctly assign models for HyperLynx SI. Okay, but before we hop into that, actually, I just want to make sure that everyone's kind of clear on what Oasis Sales and TriLogic can really offer you in the way of electronic design and simulation through Mentor Graphics. So these are all the products that we both cover through the Mentor Graphics portfolio, and that is First off, I'll talk about Expedition PCB. So that is a very powerful enterprise level solution for printed circuit board design. Very capable, very robust tool that allows for high-end data management capabilities as well as concurrency through our different teams. Okay. PAD's also a very well capable tool for printed circuit board design. It allows us to really complete some very complex designs without having all of the enterprise wraparound for data management, collaboration, or things like that. Okay. What we're going to be focusing on today is HyperLynx, and I'm assuming that most people are at least familiar with HyperLynx today, but if you're not, HyperLynx is a family of simulation tools. Okay, so HyperLynx includes signal integrity, which we'll be talking about today, power integrity for DC drop, as well as AC analysis on your voltage planes. There is HyperLynx DRC, which is a graphical EMI rule checker to make sure that your boards aren't going to be having too much EMI or causing issues like that. Okay, as well as there are some analog solutions within the HyperLynx family as well. And on kind of the manufacturing side of printed circuit board design, we have Valor. So what Valor allows us to do is manufacturing and assembly checks on the board level and get those fixed as early as possible in the design cycle and increase your yield in manufacturing. Okay, so how do we model ICs in HyperLynx SI? And I'm assuming most people are at least familiar with what IBIS models kind of are, but IBIS models are behavioral models that model the analog behavior of I/O buffers. Okay, so these are really what we are going to be using predominantly in the HyperLynx SI flow in order to accurately simulate our drivers, receivers, in order to get that rise and fall time through the interconnect that we're trying to design. Okay, so these are an industry standard. Typically, they're created by the silicon vendor. And that, I always get the question on where do I get this IBIS model? Where's the best place to find IBIS models? And 99% of the time, you can go directly to the vendor and they should have those IBIS models provided for the component that you're using. Okay, so if you're not able to find that, we do have the ability to manually create those, but so the silicon vendors actually pass these tests in order to create these IBIS models. Okay, so they're created by simulating SPICE models of the I/O buffers at different SPICE test bench levels. Okay, so it's again an IEEE standard, industry standard that models the actual inner workings of your components in order to use in simulation. So like I said before, it's very important in order to have accurate simulation results to use correct models as well as models that have been verified by those vendors. Okay, so that's definitely the best space to work in for those models. All right, another type of model that we can use to model different types of components on the board are EBD. Okay, so what EBD models are essentially an electrical board description. So the best example that I have of this is a DIM module. So if we're purchasing a DIM module, typically that vendor will have already provided this EBD model. It's essentially a black box description of that module. So they have already passed validation of the signal integrity effects for that particular DIM module, and then we are able to plug that into our system and have it as part of our printed circuit board design that we can simulate. Okay, so the only really remaining unknown that we have with EBD models is how it is going to react with our system. The vendor selling the DIM module should have already validated the signal integrity effects of their DIM module. Okay, so that's the EBD, the black box, very easy to plug into simulations and work with and accurately model that DIM module in your system. Okay, so when we do get models, it's important to understand kind of what they're made up of, as well as kind of verify them to make sure that there's no syntactual errors or any pin mapping errors, for example. And within the HyperLynx SI space, we have the visual IBIS editor. This actually allows us to open up an IBIS model, which is essentially just a bunch of text that describes the pins, which describes the clamp diodes, which describes the CMOS effects of those ICs that we're using. Okay, so I'll show how we can actually use that visual IBIS editor to check for syntax, numerical errors, And then we can actually just simulate those in LineSim very quickly to make sure that they're going to work how we believe that they should work. Okay, so I haven't seen any questions yet, but that's fine. I just wanted to remind everyone that there is that chat box in GoToMeeting in order to ask questions, and I'll hopefully get to those while we're discussing. Okay, so assigning models. So very easy process within the LineSim environment. So if you're unfamiliar with LineSim, I'll walk through this after we describe it a little bit. We have the ability to draw an interconnect on the LineSim environment. LineSim is that pre-layout what-if signal integrity environment where we can help design our interconnects, the number of vias, what layer it's going to be routed on, the trace width. We can all play around with those types of characteristics to see how this signal is going to propagate down our printed circuit board. Okay, very easy to assign models to this. All you have to do is double click on the driver or the receiver and open up this assign dialog box. Okay, so you'll see here on that picture, I've got U1 pin 1 and U1 pin 2, and I need to assign models to that. All I have to do is assign or click select when I have one of those pins selected and navigate to the correct IBIS model. Okay, so within the IBIS model, we can actually see the devices that make up that model. You'll see we have library is the actual IBIS model, the device or subcircuit that is defined in that IBIS model, and then all of the signals that are defined in that IBIS model as well. And within the HyperLynx environment and IBIS models, thanks to this, we can assign on a per signal basis. So you'll see we have a signal pin here, or we can actually choose the pin of that device. So you know that you're using pin 9 on your Vertex FPGA, for example. We can just assign that pin to use that correct pin modeling off of that IBIS model. Very easy to set that up. Okay. On the flip side of that, to assign models in the BoardSim environment, we first have to select a net and then click the assign models or edit values for the components. And that opens up this exact same dialog box. So whether we are assigning models in the LineSim environment or in the BoardSim environment, it's the exact same process. Okay, so that makes it a little bit simpler. Only have to understand one dialog box and how to use that. Okay, so saving models. Like I said, we go through this whole effort of first obtaining the IBIS models, and then we go through and map which IBIS model goes to which component. Okay, that's kind of a time-intensive process in order to assign those models correctly. Now we have the ability to actually save models in order to use them in future designs. Very, very powerful way to quickly simulate with accurate IBIS model mappings. Okay, so the first thing is called a .ref or reference file. And what this does is it maps models to ICs based solely on reference designator. Okay, so this is a powerful way to do it in a revision type design cycle. So if I am working on revision A of my board, I can create a reference file, and every time I see a U1 or U2, it's automatically going to use this particular model. Okay, so that's how a reference file works. All it does is map the IBIS model to the reference designator. And that can be done in the pull down of HyperLynx BoardSim in models, assign models by reference designator. Okay, so that's kind of what the dialog box looks like for the reference file mapper. All we have to do is select the reference designator and then select the model and save it to that REF file. Okay, so the next way, and maybe the more powerful way, is to actually use a QPI file or QPL file. And what this does, instead of using the reference designator, it essentially just allows us to map models to part numbers. Okay, so this is a much more powerful way to share mapping between project to project. So if we're using the same FPGA, the same DDR chip, anything like that, we can assign that to the part number or part name and then use that in future designs. Okay, so obviously reference designators are going to change the design to design, but part numbers or part names, we might use that same part on 10 different designs, and we only have to assign that IBIS model once in order to accurately model that. Okay, so I did want to talk a little bit about modeling packages and connectors. So this is always another question of how to do this, or it's difficult to understand how to do this. And what we can do here is essentially use S parameters. Okay, so I'm sure everyone's at least heard the term S parameters. And what that allows us to do is very accurately model packages or connectors through our board. Okay, so again, these can be usually found from the vendor. The connector vendors usually have models for this. And all we have to do, I will go through this process, is assign a touchtone model. A touchtone S parameter, almost synonymous there. And it allows us to actually view the frequency response and the insertion loss of that S parameter through the interconnect. Okay. So here in the LineSim example I have down here, we actually have an S parameter port. So you'll see I dropped a S parameter model and just double click on there again to assign that touchstone model. Okay. So you'll see this is a 4-port model here that's got port 1 and 3 on the left-hand side, port 2 and 4 on the right-hand side, and that's essentially all we had to do to accurately model this connector or a particular package that we want to take into effect of our simulations. Okay. We also have the ability to use SLM models, which accurately model connectors as well. And what we can do through there is everyone should at least be somewhat familiar with HyperLynx transmission line models, and that's kind of that cylinder for a transmission line. If you just double click on that, it brings open the transmission line type properties. And if you go down to the bottom left, we can show connector and actually map it to those SLM models. Okay, so that's typically kind of what Symantec or other connector vendors will provide, is an SLM model, and it's very easy to incorporate it into our HyperLynx system as well. Okay. I think that's been enough slides. Again, I don't see any other questions, but that's totally fine. So I'm going to hop into the actual HyperLynx demo and kind of play around with some model assignments to make sure everything's working correctly. All right, so this is HyperLynx. This is just the start menu. For licensing purposes, I'm just using a HyperLynx SI gigahertz license. Okay, so that is the high-end HyperLynx license, but I'm going to open up first a LineSim freeform schematic. Okay, so when I first open this, this is our LineSim environment. Again, LineSim is really powerful for interconnect design. We can see that we have some drivers over here on the left-hand side going through our interconnects. So we have a resistor, transmission line, we're modeling vias as well. Again, another transmission line, layer changes, and then we're actually ending up at our receiver here on the right-hand side. Okay, so without any model assignment, you can see that we don't have any models assigned to these components because we have question marks there. All right, so if I try and simulate this without actually assigning a model, we're going to get an error when we're trying to simulate this. So no IC output, no driver, so we can't actually simulate, which makes sense. We're not giving it any response in order to simulate it with. All right. So in order to assign that model, really easy, I can just double click on any of these drivers or receivers here. And this brings open up our assign models dialog box. Okay, so you'll see question marks for any component that does not have a model currently assigned to it. Okay, so in order to do that, I'm just going to hit on select, and that opens up our select a model dialog box. Okay, so for example, here is most of what HyperLynx ships with. I've only added a few other IBIS models just to play around with, but this is basically out of the box settings that we have for HyperLynx. So these are all kind of what you currently have access to if you haven't gone down and downloaded any other IBIS models. Okay. So for this, I'm just going to quickly assign a vertex 4. We'll see that we have a vertex 4 device here. And if I want, I can choose by which signal name I want to model with, or by which pin name, pin number that is. So I can select and hit OK. All right, so after I've done that, you will see that U1 changes from that question mark to a actual green icon. Okay. So to change if this is an input or output, so some IBIS models allow pins to be input outputs, some only input, some only outputs. But for example, here we can see at the top, at the buffer settings, currently it's set to an input. So if I hit OK here on U170, you'll see that it kind of looks strange here because I didn't change that to an output. So if I want, I can just double click, turn that back to an output, and now it looks like a much more actual design here. Okay. So in order to quickly assign the rest of these, what I can do is I can hit copy and choose U370, which is this other driver here, and hit paste. Okay, so that pastes those exact same settings to U3. All right, so that's easily done right there. So now, in order to assign the receivers, I'm going to do the exact same process that we did right there. And just to make it real quick, I'm going to choose a general CMOS I/O pin and hit OK. All right, so again, this time we only see that it's an input. So this particular signal is only an input signal. So I can hit copy and hit paste on that U4 there and hit OK. Okay, so that is how we assign those models in the LineSim environment. If I actually want to take a look at that IBIS model, what I can do here is I can click this icon here, which is Edit IBIS IC Models. Okay, I believe in here we can also go to the Models pull-down tab and click on the Edit IBIS IC Models. Okay, so that opens up the visual IBIS editor that I was talking about earlier. So what this allows us to do is if I want to go File, Open, I can actually point to a particular IBIS model. And these are just some models I threw in this to work with real quickly. I'll just double click on this Vertex 4. Okay, so if you're unfamiliar with how IBIS models are made, it's again kind of a text file that essentially shows all of our different drive strengths, our pin, our temperature thresholds, our package delays. We can see our parasitic here defined. So there's a lot of stuff going on in this particular IBIS model. So as soon as I open that up, on the left-hand side, you'll actually see we have a little navigator that allows us to double-click on our different models and pop down directly to that section. Okay. So at the top, we'll just have some disclaimers, some notes from the manufacturer, for example. All right. If I want, I can actually expand these particular fields in our navigator. Okay. So if I know I'm using this model of the LVTTL F2, we can actually look at our temperature range. If I double click there, it pulls us down right to that section. So this is a really good IBIS editor that allows us to learn kind of the anatomy of an IBIS model and understand what the model is going to actually look at. Okay. So there's two things that I want to show in here. And the first thing is if I click on this, this is going to check for syntax errors within this particular IBIS model. Probably a good idea if you're working with a vendor for the first time, you get an IBIS model to run this through and click on the IBIS spec conformance. So that'll run through here and output any warnings or errors or cautions in the output window down there at the bottom. Okay, so it's pretty important to look through here just to take a look to see if anything looks like we will not be able to use this model correctly. Okay, so we can look at our different cautions and nothing really is standing out to say, wow, we really shouldn't use this model because it really doesn't look like it's set up correctly. So errors are going to be syntax errors, and if there's an error prevalent, we will not be able to actually use that in simulation most likely. It's going to run into a syntax error when we're actually simulating with this particular model. So that's the first thing we want to do with a new IBIS model is just to check to make sure that there's no glaring syntax errors that will not allow us to use it. The next thing that we can actually do is look at the IV characteristics. So if I click on my icon here on this graph, this is actually viewing the IBIS data that is contained in information within this IBIS model. Okay, so this opens up the IBIS data, and we can see we have our component, which model we're using. I can click on all of these pull down bars, and I can actually look at the different models associated or assigned in this IBIS model, and actually look at which signal as well. Okay, so it gives us just some pin information, the actual capacitance and voltage that's defined in this IBIS model. So if you want to compare this to the data sheet really quickly, just to make sure that we are on the right track, this is an easier way to view this type of data than just going through the actual text data of the IBIS model. Okay, so for some, we can actually look at the power clamping diode, the ground clamping diode. We can see all of our IV characteristics for these different diodes. So this is getting pretty far down in the IC and the actual how the IC is going to be working with these different clamp diodes. Okay, so if I want, I can look at a falling waveform, a falling edge. So again, IV characteristics of this particular IBIS model that we have chosen. Okay. So those are the major benefits of using the IBIS editor. So we can verify, we can look into the IBIS model, and we can actually see the IC characteristics. All right. So now, once I actually have the driver and receiver assigned, now I can actually run a simulation without any errors. Okay. Very easy to go ahead and do that. The next thing I want to talk about within the LineSim environment before we go ahead and move on to the BoardSim is how to correctly assign those S parameter models that I was talking about. So if I want, I can add an S parameter to my schematic. So that will pop open into the form of J1. Okay. So J1, just a random, looks like a connector, it might assume, but nothing assigned to it yet. All I have to do is double click on this. And this will allow me to look towards an S parameter. So unfortunately, I'm not going to be covering today how to create S parameters in a HyperLynx environment. We do have that ability, but this just allows me to point to an S parameter that we already have in our library. Okay. So for example, I'm going to use this example S4P. Okay. So as soon as I click on it down there, it actually shows us which ports are going to be placed onto the schematic. All right. So if I'll just hit OK, that automatically puts port 1 and 3 on the left-hand side, port 2 and 4 on the right-hand side. So if I actually want to take a look at this a little bit stronger, I can double-click on this and hit View Model File. What this actually will bring up is the Touchstone Viewer. Okay, so this will just take a second to instantiate. And within the Touchstone Viewer, it opens up what this model actually looks like. So for right now, I can look at the frequency response as well as the insertion loss if I would like. Okay, so this just kind of understands what the S parameter model is actually modeling. But what I want to do here, this is just kind of general usage, but now if I right click on the actual model, I can hit View Connectivity. This is very powerful because it actually allows me to see which port is connected to which port. Okay, so this is allowing me to verify that that automatic port mapping was done correctly. Okay, so if I click on port 2 or 3, you can see that those strong and weak settings are changing. So if I'm looking at port 1, I can see that it's connected weakly to port 2 and 4. So weakly, we can kind of consider that to be coupling of some sort. Okay, but strong, so we can see ports 1 and 3 are strongly connected through some sort of electrical connection. Okay, so if I want to, I got to make sure that 1 and 3 are connected and 2 or 4 connected. So looking back at this automatic mapping, we can see that that's not the case. We have port 1 and 2 connected and port 3 and 4 connected. So what I can do here is I can, in the S parameter assignment dialog box, I can choose which ports are on which side. So now I've got port 1 and 2 on the left-hand side, port 3 and 4 on the right-hand side. Hit OK, and now we have port 1 and 3 electrically connected, port 2 and 4 electrically connected. And if I want, I can actually go ahead and assign, use this in my simulation. Okay, so to actually use an S parameter in simulation, we do have to connect this between transmission lines. So for example, if I assign this port, I just have to drag that port to be connected there and there. now I can actually use this S parameter in my simulation. Okay, so what we've done here is assign an S parameter. We have validated that the S parameter connections are correct, and now we've actually put it in our schematic so we can actually do a simulation with it. Okay, and we can see that just inputting that S parameter, if I use this waveform viewer, I can turn off those previous results. So you can see that that S parameter has some drastic effects. Okay, so that's all I'm going to talk about on the LineSim environment. Let's hop into the BoardSim environment. I'm just going to go File, Close within this HyperLynx tool. Okay, so now what I want to do is actually open up a BoardSim HyperLynx file. Okay, so if you're unfamiliar with the BoardSim environment, this is essentially our PCB file that we brought in from any CAD tool. Okay, so that can be in the form of ODB++, which is typically the most recommended way. That can be a CCE file from Expedition, or it can be an HYP file from any CAD tool. Yeah. And what that should bring in is our StackUp editor. So this is our entire StackUp. If I just look at this real quick, this has a lot of our StackUp information. All of this should have been brought over from the CAD tool. Very important in signal integrity simulation for reference planes, for dielectric constant. Very important in making sure that this information is correct. Okay. So to actually go ahead and simulate within here, again, I'm not going to go into too much detail of what we can do within the HyperLynx environment, but there is some powerful SI capabilities that we can do. We can just run an interactive simulation in that digital oscilloscope. We can sweep different parameters that we have control over. We have the ability to do a batch wizard across this entire design, or some more high-end capabilities is running a DDRX simulation, which runs it through kind of our DDR wizard and compares those to JetX standards. We also have the ability to do SerDes analysis and channel analysis within HyperLynx. Okay, so all of those sound great, very powerful simulations that we can run. But the most important thing before we run those simulations is ensuring that we have models assigned correctly. Okay. So first I am going to look at my models and look at my library paths. Okay. So this is where I can set the directories for my models that I'm able to use. Okay. So if I want, I can look here and look at my different library paths that I'm going to be looking at. Okay, so if you're trying to assign an IBIS model and you can't find it for whatever reason, go into here and just edit a new library mile path to point to a new folder. Okay, so I can just hit add and browse to a folder with models in it. And I can just hit select that folder, and now we'll be able to actually point to the IBIS model. Very simple to do that. Okay, so we'll also be talking in a little bit. This is where we're going to be pointing to our qualified part list file, or QPL file. And again, QPL files assign IBIS models on a part number or part name basis. Okay, so to first assign models to components, I'm going to click on the select net name for SI analysis. This dialog allows me to actually look at all of my different nets in this design. Okay, so I can actually go ahead and filter all of these nets. I can hit apply, and that'll filter it for only nets that have data in the net name. And so if I select a net, it'll kind of highlight that in the workspace and allow me to actually just see that particular net a little bit clearer. What I can do here is I'm just going to only work with 17, 18, and 19. Mem data 17, 18, and 19. Just to make this easy, I'm just going to work with these three nets throughout a few designs to show how model assignment can work. Okay. So again, if I wanted to, and I wanted to simulate these nets, I selected them, I hit this, the oscilloscope icon, and start that simulation. But we haven't assigned any IC models yet, so we obviously can't simulate this yet. So there's no drive strength, there's no receiver impedance assigned. There's really nothing to simulate here without those models. Okay, so now what I can do is, with those 3 nets selected, very important to remember that, I can either go assign models by net in the models dialog pull down, or I can click on this icon here for assigning models or edit values for those components. And this will pop open the different models that I have assigned for these components, okay? So we can see that R22, all these different resistors, these are actually automatically defined just by the value that's been assigned to those parts in our CAD tool. Okay, so that comes across correctly. The only thing that we would want to do here, if it's critical, is to set parasitics. Okay, so you can see here, to set a parasitic, we do have to use an IBIS model because those types of RLC parasitics can be defined in that IBIS model. Okay. So again, here, I'm going to just work on U30 and U57 because those are the drivers and receivers that we're working with here. Okay, so if you zoom in the BoardSim tool, we'll see U57 here and the U30 over here is the receiver. So I'm going to select the model again. And again, just for making it simple, I'm going to use that vertex 4 pin 9 one more time. I work with that one fairly often. And set that to my output model. All right, I'm going to again copy that. And for every U30, I'm just going to paste that here. All right, very easy. We've already set the output. Now, for U57, I'm going to hit select. And this time, I'm going to use just a general I/O 3.3 volt signal. Okay. Again, very important to go to your manufacturer, your vendor, and get the IBIS model specific to your needs. And if you need help with that, please let me know. I can hopefully help you point you to the right direction on that. Okay. So now I'm going to copy that, paste it to these other U57s, and there we go. We've gone ahead and assigned those models for us. All right. So now that I've assigned those models, what I can do to just kind of overlook all of the models that I've assigned in this particular design is if I go Models, Manage Assign Models. This is a very good dialog box to become familiar with, I think, because it shows you the net name, it shows you the pin name, and it shows you any associated nets to that particular net, as well as the model that we've assigned towards it. Okay? So this is really helpful in understanding what type of model, if it's an input, if it's an output, what the part number is, what IBIS model it is. It basically gives us all the information for modeling in this one particular dialog box. All right, so with that, I'm just going to go ahead and run that simulation one more time. And now that we've assigned the model, it will run without error. All right, so again, we can do a lot of stuff in here with simulation. We can try and figure out why there's some ringing, maybe why there's some overshoot it may look like. You can do that all within the Hyperlinks environment, and that's why setting up models is so critical and so important to make sure that's set up correctly. All right. Okay, so now if I want to, again, look at that REF file for reference designator model assignment and the QPL file for part number assignment, that's all done through the models pull down bar. Okay, so you'll see we've got models. We have in the second and third options here are assign models and values by reference designator and that part name. Okay, so if I look at the reference designator, for example, this pulls open the dialog box that allows me to look at all of my different reference designators in this design. Okay. I have a few different things that I can do within here. I can click on show only parts without models. That's kind of nice to kind of filter this out. This allows us to only see the components that don't have an assigned model with it currently. Okay, I do want to point out that real quickly, we have in our different ICs, we do have the ability to do PI models. I'm not going to be talking about that today. This is only for power integrity analysis. for either a voltage regulator model or a DC sink. So let's just try and not look at that too much. But we also have the IC models. Okay, so as soon as I click on an IC model, it gives us that reference designator. It also gives us the part name of that reference designator. Okay, so just like we had done in the Select Models dialog box, I can browse to whichever type of model I want to and assign it to that IC. Okay, and down below, this actually shows us what the REF file is made up of. Okay, so we'll see that now we have this IC here that I just assigned to this Motorola IBIS model, and we can see that it is the correct assignment that we just created. So this is what the actual REF file is made up of. Okay, so very easy to do this. I can just assign different models to it, and there you go. Keep building this QPL file. Again, QPL is for reference designator. These can be used for revisions between boards, or if you change some routing, for example, we can still use this REF file with the same reference designators and automatically assign those models for it. Okay, so to do that, all I have to go here is go File, and I can go Save As. And just save this as a detailed batch analysis.ref. And the way that we use this REF file is to place it into your hyperlinks directory, and it will automatically use that REF mapping. Okay, so just in the project directory of your current project of hyperlinks you're working with, you place that REF file there, and it automatically uses it. Okay. So that's an REF file. And if I wanted to, I could actually take a look at that in just a text browser. So I just open this up in a text browser, and as you can see, all it shows is reference designator and either value for those discrete components, or if I scroll all the way down, I think it's going to be at the bottom, are U32, U33, U34, U35, up to U40 are pointing to that IBIS model. Okay, so that's kind of what the anatomy of that REF file looks like. All right. So now, if I want to go to models, assign models by part name, QPL file, this is definitely more powerful if I'm trying to exchange data between Hyperlinks project and Hyperlinks project. If I'm using the same components on completely different printed circuit board designs, this will still always assign the correct IBIS model that I've assigned it towards in that simulation. Okay. So again, this is a really simple dialog box to get familiar with. In the part type, I can look at all of these different part types that exist in my project. Okay. So if I want, I can look at my power ICs and look at only those ICs that have been assigned as power ICs. Or I can look at just my capacitors, and it actually gives us the different part names of those capacitors. So if you know you're working with some sort of capacitor that we really, really need to model the parasitics for, I can actually just assign a value for that, or I can actually select a model, an IBIS model for those capacitors. Okay. But for ICs, all I have to do is drag a part number and select an IBIS model for it. So for this part name, 224LC S5 2ST, anytime this is used in a future Hyperlinks design, it's going to automatically use the demo1.ibis component model 1. Okay, so as soon as I hit assign, you'll see that this QPL file is starting to get built up. Okay, so really easy to, again, work with this. By selecting those different part numbers. Okay, so if I select these next ones, I can just go ahead and start assigning different models towards them. All right, again, once I've built this up, I can go File, Save As, and save this as a QPL file. So I'm just going to call this Kyle Board QPL file. And again, if I want to, I can look in there edit this with Notepad++, and this time we're actually seeing, instead of reference designators, we're looking at it's an IC, it automatically knows that, what part number it is, any description, this is just a blank description field that I didn't add anything in, and then which IBIS model and which component of that IBIS model we're going to be using for those different part numbers. Okay. All right, so I can save that. And again, if I want to go to Manage Assigned Models, we'll see that we have our different IBIS models that we just assigned. Okay, so again, I really think this dialog box is powerful, really easy to work with as well. Okay. All right, so we've gone ahead and created our IBIS file, or our QPL file. And now I'm going to open up a different board and just point to that QPL file and automatically have those models assigned. Okay, so to point to that QPL file, again, we go to Models and Edit Library Paths, Edit Model Library Paths. Here, I can point to that QPL file just here. So that's all we have to do in order to use that existing QPL file we've created. I go here, hit Add File, and just navigate directly to it. Okay, so there's that QPL file just created a few minutes ago. Hit Open, and now it's automatically going to assign those models for us. Very easy to work with. Okay. All right, so I see a few questions that I'll respond to you directly. But other than that, that's all I was going to show today. Again, thank you for attending today. And here is my contact information one more time. So if you have any questions on Hyperlinks or just anything mentor related, I'm always happy to help or get you the correct contact information of someone who can. So thanks again for attending. I hope you all have a great day.